Good morning. Thanks for you who have managed to get out of bed. I know it's difficult on the second day of a conference. Today I'm going to give an overview of the environmental impact of marine renewable energy. I know better than you, Gary. I just want to make a quick statement and put it in context to start with. 4 or 5 years ago, the UK was undoubted world leader in the development of marine renewable energy, particularly tidal and wave. Since then, with the credit crunch and a distinct lack of investment from central government, this is not necessarily the case. And the noises that are being made from our government at the moment doesn't suggest that the situation is going to improve much in the future. Meanwhile, other parts of the world have taken this to their hearts and see the future and the potential of it and are spending and investing huge amounts of money in renewable energy technology. South Korea has just opened its first tidal barrage. It's building 4 others. It's spending $300 million on a tidal current farm off Incheon. China is utilizing marine renewable energy to power all its offshore islands and is in the process of installing wave, tidal and wind generators on those islands to give them a future for security for their energy. And since the nuclear disaster in Japan, Japan has focused much more on the development of offshore wind technology, particularly floating wind platforms, and they consider themselves the world leader in that now. Now, in the UK, with perhaps not so much in other parts of the world, one of the potential restrictions of how we can actually develop the industry is the concern over the environmental impacts that these devices may have. So what I want to try and do today is have a look at these major potential impacts, what evidence we have for their impacts on populations of organisms, and then hopefully come to some sort of conclusion of what the real issues are and how we may move forward. So what I want to do is actually look at the potential negative environmental impacts, consider any potential positive benefits to the marine ecosystem that introducing these devices may have, and then have a summary of what I feel are the likely concerns and what is really important in terms of the actual impact, and come up with some conclusions at the end. So I'm going to assess just the biological component today, mainly that's because my area of expertise, but also because of the time. I'm going to look at operational impact. We know that constructing all sorts of structures in the marine environment has an impact, and that's not within doubt. What we want to know is once the things are there, what's their operational impact? I won't be looking at tidal barrages because that's another almost literally kettle of fish altogether. We just look at wave, tidal and offshore wind devices and what their impact is. So firstly then, I want to have a look at the potential negative environmental impacts on biodiversity of putting these devices in the water. And we're going to have a look at 4 main areas of concern: collision with organisms, the effect of anthropogenic noise, electromagnetism and how that may affect organisms, and then the provision of physical structure in an area which is changing the natural substrate. When you come to collision hazards, particularly with birds, these seem to be the most high-profile concern globally in terms of how particularly wind turbines are impacting organisms. And you can find, if you search, all sorts of headlines on wind farm, threat to bird life, etc. And a recent estimate suggested that up to 40,000 bird deaths a year occur in the US alone due to wind turbines. And this seems a significant number. But the important thing is we need to put this into context in terms of how many unnatural bird deaths there are. Now, hopefully you can see this if you have a look at the TVs. This might not be so clear on here. This is a graph from the US Forestry Commission, research published in 2005, estimating the number of bird deaths that you have unnaturally in the US. And what you can see is that wind turbines are a fraction of this, around about 40,000 a year. A similar sort of analysis suggests that over 100 million bird deaths a year are caused by domestic cats, and around about 500 or more million bird deaths occurred from flying into buildings. So even if you multiply the number of wind farms by 100 that you've got in the US, it's still going to be a tiny fraction of the total bird deaths you've got in the UK, in the US, and a small percentage of what domestic cats kill. So if you want to save birds, then just get rid of domestic cats is one argument that you can make. So this is data primarily from land. What about offshore wind farms? Well, the data suggests that the number of collisions from offshore wind farms are much lower than they are on land, particularly when you move to larger, slower moving turbines that you find offshore. the bigger and the slower moving the turbine, the less likely a bird is to collide with it. This is an interesting piece of work done by Martin Attrill in 2009, where they had data on the passage of migrating eider ducks. This is between Sweden and Denmark. And the top diagram here demonstrates the path that was taken by these migrating eider ducks before construction of the wind farm, and the dots indicate where the wind farm is going to be. And the lower panel shows the movement of these ducks once the wind farm was constructed. And what you can actually see is the vast majority of the birds actually alter their course to avoid the wind farm and fly around it. And they calculated that this would be an extra 500 meters flight in a migration of 1,400 kilometers, and suggested that that is not going to have any impact necessarily on their energetics or their ability to successfully breed. The question is, of course, if you cover the sea in wind farms and you don't provide the corridors for these organisms to migrate, you may well start making an impact. At the moment, the scale of what we're putting in the water is not really affecting migration such as these eider ducks. As a slight aside, something that I find quite peculiar is, are we actually putting the right type of wind turbine in the marine environment? What we're doing is exporting terrestrial technology into the marine environment. And on land, turbines need to be quite high because the wind speed at 30 meters or 40 meters is quite a lot more than it is on the ground. This is not necessarily the case at the sea. Sea level wind tends to be very similar to what it is at 40 meters up. But at the moment, we are building windmills quite intensively on this design from the land. And Fergal Brennan, who works for Cranfield University, said there's a very good reason why boats don't look like cars. And that's because it's a very different environment. And there are all sorts of designs like the one you see here for vertical axis turbines, which actually reduce a lot of the problems of reliability and collision by actually utilizing completely different technology. And these are much more suitable for floating platforms because the center of gravity is lower. They don't need pile driving to get them into the seabed. So we're actually stampeding at the moment to put huge amounts of windmills in the marine environment without that perhaps consideration whether they're the best thing for the marine environment in terms of efficiency. There's a very similar process when we come to tidal turbines underwater. The slower and larger the turbine, the less likely it is that going to get collision from marine mammals. And they seem to manage quite happily to avoid larger, slower turbines. There is some suggestion that some diving birds might be vulnerable, and a paper that's just come out this year by Furness et al. Tried to estimate the risk, the likely risk to diving birds, such as puffins and cormorants. And because they don't have the sophisticated mechanisms that marine mammals do, they may be more susceptible. But this is just, again, a hypothetical paper, and we haven't had a chance to test that. And obviously it depends on the depth of the turbines, etc. as well. Where we have the most evidence, certainly in the UK, is from Strangford Lough, where we have the longest standing current turbine in operation. And this is in an area of extreme marine conservation importance and where we have a grey seal colony. So Queen's University have been monitoring intensively the movements of grey seals and the impact of the turbines in the loch. And after 3 years of monitoring, this quote was given by Graham Savage, who's leading it. The 500,000 movements recorded so far suggest turbines and seals avoid one another. Again, the key here is if you have huge numbers of these, do the marine mammals avoid it so much they're going to move somewhere else, and that may affect their populations. But at the moment, there's very little evidence for collision between the marine mammals and these turbines. So summary then for collision, for bird kills, offshore seems much less of a problem than on land, particularly with newer, larger turbines, which move much slower. The evidence suggests that migrating birds can avoid and fly around turbines without necessarily dramatically affecting their energetics, but that is dependent on the scale of the wind farms, clearly. And at the moment, we have little evidence of collision problem between marine mammals and tidal stream devices, but again, that might be a subject of scale. Birds are unknown at the moment as well, but the suggestion is it's probably going to be fairly limited, and certainly much less than for wind turbines. The key issue then is the wider disturbance, and we won't know that until we have significant scale devices and wind farms in the sea. The next thing I want to have a look at, which is a major concern, and there are global organisations working on the effect of operational noise from all sorts of anthropogenic sources, is what sort of noise is given out by renewable energy devices. What we need to consider, of course, that an impact of noise depends entirely on its frequency as well as levels. If we have a really loud dog whistle, it's not going to bother us because we can't hear it, but clearly other organisms are going to be majorly affected by that sort of level. From the work that's been done on wind farms, which have these piles which will vibrate and give off noise, this is the Horns Rev off Denmark. The peak sound coming from these devices is 150 and 300 hertz. And there's no sound above 800 hertz. So it's all very low frequency. So in this diagram, which gives you a general idea of where noise is coming from in the marine environment from different sources, you can see that the noise from wind farms is coming at the sort of top end of ship noise, and there's no noise in the upper end where, for example, you get sperm whale calls and a lot of the effect of some other environmental impacts like rain, etc., and wind. So what we need to do then is try to relate this frequency to the hearing range of marine mammals. And hopefully you can see this. We have 3 diagrams here, which is actually from the US Office of Naval Research, who've put a lot of work into this because they're worried about clearly the impact of their sonars, etc. We have 3 ranges here of susceptibility. So the lower point in that graph is the most susceptible, where the organisms are hearing at the greatest acuity. And then at the ends, their sensitivity gets less. So if we actually put these 2 graphs that we've got the information for on this, what you can see is that for porpoises and seals, the noise frequency is at the edge of their detectability in the main range they use, but it's slap bang in the middle of the mysticeti, which are the baleen whales, who actually, as most people know, communicate in that sort of low frequency and have had major impacts from shipping. So if we look at the work that's been done trying to analyse what the effect of noise has been, this is mainly done again in Scandinavia. What they found, that they reckon that the noise from Horns Rev, a porpoise could probably hear it from 100 metres away at the edge of its threshold, but after that it probably couldn't hear the noise at all. Seals can pick it up a little bit more, and fish, which I haven't got the diagram here for, are more sensitive to this frequency of noise and probably could hear the noise up to 4 kilometres away. The work that's been done on the Nysted wind farm shows no evidence of any changes in seal behaviour. There's a colony 4 kilometres away. And actually, Larson and Guillemette suggest that seabirds may actually use noise as a cue in their migration to avoid these wind farms. So summary then for noise from what we know. Most noise from turbines is only just in the hearing range of coastal marine mammals. Fish are more sensitive, but Thompson et al. Suggest that effects should be restricted to very close ranges, and we'll come back to this. There's little evidence of noise impact on mammals beyond construction, and construction, particularly pile driving, does have a dramatic impact on marine mammals. That really affects them, and they leave the vicinity. But the work that's been done following it through into operation suggests that a lot of these populations have returned and are starting to build up despite the operational noise. So when we actually come to looking at tidal and wave devices, clearly operationally and mechanically it's important to try to judge the range of major frequencies coming from these devices and try to limit what they're actually producing if we can in the key areas for these sensitive organisms. The third subject area I want to have a look at is electromagnetic fields, and this is these are produced by subsurface electric cables, which we have out in the marine environment to some degree already. And the evidence suggests that a range of marine organisms detect and actually use electromagnetic fields in feeding and detecting prey, particularly elasmobranchs, the rays, the sharks, but bony fish and marine mammals are also sensitive and use this as well. However, even though there's been quite a lot of work on this, it suggests that a few species are actively attracted to electromagnetic fields. Perhaps they mimic a dying fish movement or something like this, and can detect these fields up to 300 meters or so away. But apart from that behavioral change, there's very little evidence that there are any further consequences of this in terms of whether it affects their population, whether it affects them remaining in an area. The scale issue here is obviously important. When you have massive wind farms with a big network of cables, will that have an impact? But Oman and et al. In 2007 suggested there is very limited evidence for any wide impact of offshore power cables on marine organisms. So until we see really big scale devices, we really don't know, and the evidence is limited that really it's going to have a population level effect. So the final impact is actually putting physical structure into the marine environment. And clearly, constructing in soft sediment changes the nature of the seabed, replacing things like soft sand or shingle with hard material. And there has been estimated of the habitat that's been lost at wind farms. This was done by Wilson in 2007. And you lose around about 500 square meters of seabed for every turbine you put down. And then obviously you lose some water column as well because you have the pile in there. So while you actually replace the habitat, you're actually providing a new one. And obviously this is major debates in conservation about changing habitats. But what you are doing, and as was recognized, you're providing some sort of structural habitat, and that links to positive impacts. So just taking a little step back, one of the arguments is what we're doing is replacing a natural habitat with an unnatural one. But what we have to come to realize is the vast majority of the seabed, particularly around the UK, is not actually natural. And this is a really interesting diagram that's mentioned by Callum Roberts in his Unnatural History of the Sea book. I've managed to dig it out. Now, hopefully you can see the televisions here because it's quite interesting. This is from Olson's 1883 Piscatorial Atlas of the North Sea. And it gives a distribution of all the different fishes, but also the seabed characteristics. And what you can see here is this great big red area in the southern North Sea, which is just labelled oysters. And in 1883, most of the southern North Sea was a massive oyster bed, which was being actively commercially exploited. It was last harvested in 1936, but by 1970, there were no oysters left. And this is due to the impact of the extensive commercial steam trawling which has occurred since then. So we have lost extensive areas of hard substrate from the marine environment. All the grey shadows you can see in there are rocky reef areas that existed in the North Sea and the Channel. Many of those don't exist anyway. So a lot of soft sediment that we have is not necessarily the natural state that would have been there 150 years ago. So could it be argued that what we may be able to do with artificial reefs, including structures like this in the marine environment, they're actually replacing some of the lost hard substrate that we've lost over the last 150 years, therefore providing habitat for particularly filter feeding bivalves, which provide an important ecological function in filtering the whole water. The massive amount of ecological function we've lost from losing oyster beds and mussel beds around the UK is probably immeasurable in terms of how it helps purify the water. But certainly the evidence is that putting these things in the environment actually increases production and diversity at the locality. And here's just a couple of examples how physical structure can boost fisheries populations, for example. This is work by Dan Wilhelmsson and colleagues in Sweden who are putting down structures for wave energy foundations, and they varied the structure of these, trying to actually make them, enhance them for biodiversity. And what you see there, the diagram at the top, this one's got holes in, and the ones that have holes in have considerable higher numbers of crabs being caught by the local fishermen than you have where you have the same structure with no holes or where you have controls. So whether animals are moving in from the surrounding area or whether these sort of structures generate new populations is research that needs to be done for artificial reefs generally. But certainly environmental enhancement can actually give fisheries gain. Another piece of work by Dan Wilhelmsson demonstrated that also there was an increase in fish around these structures, which perhaps counters the argument that noise is really a problem for fish. The one includes gobies because they seem to attract huge numbers of gobies. But even when you look at sort of the more larger commercial fish, there are more around the monopile or within 5 meters of it than elsewhere. Again, it could be a concentration effect and more research needed, but certainly you get more fish there. So the other argument for a positive impact on the marine environment comes from the fact that renewable energy areas may act as de facto MPAs because it's impossible or illegal in some cases to actually trawl or dredge or use mobile gear through these structures. You can do it between wind piles, you can imagine that, but if you've got an extensive current farm with devices all along the bottom, you're not going to be allowed that sort of activity. So we've seen that there's some evidence that energy farms are boosting or concentrating biodiversity, and this may help in the development of further possible areas for a network of marine protected regions around the UK or elsewhere. And so the location of these could be key. At the moment, we consider where can they minimize impact, and we heard this about Sabolaria yesterday in the Thanet wind farm. But could they actually be utilized as a beneficial way of actually generating further marine protected areas? And we've kind of missed the boat a little bit in terms of this discussion on the designation of marine conservation zones, where perhaps we could have made more of a benefit from this. But Punt et al. In ecological economics say we should, when we're thinking about impact of these wind farms, perhaps we should be shifting emphasis from impact to positive benefits in terms of what we can actually get additional to the benefits from green technology and green energy. So there are fisheries consequences. Some fishing methods will be excluded, but there's great potential for increasing fisheries potential elsewhere through stock enhancement, by protection, by increasing the level of stock through the physical structure, and also housing aquaculture and other activities within these farms. Again, the co-location. And this diagram here gives some idea, if you can see any of it, through seaweed and mussel culture or long lines that can be hung out. There's potential to actually work within the community to maximize the benefits in terms of socioeconomics from these areas. So what I've done here is put together where I see the likelihood of wide-scale impacts from operations of these devices on population levels of organisms, which is what's important. And when you actually have a look at bird and mammal collisions, bird-mammal displacement, and noise impacts from the three main categories of device, the evidence suggests that the impact is going to be comparatively low, or particularly in terms of wave devices, minimal in terms of collisions particularly. There's very little evidence that at a very large scale we're going to have a massive impact from electromagnetic fields. Again, these are all down to scale. We've talked about displacement potentially from vast areas that are being covered, but we will not know that until we have those structures in the water. Where we see a really high impact on the environment is through the impact of physical structure. We are changing the environment. We are impacting biodiversity in that way. Is that a positive benefit? Could we see that as being positive for our requirements from the marine environment, from helping enhance fisheries, for helping protect parts of the seabed from activities such as fishing? So then, just to make some conclusions, my final slide. The evidence as it stands at the moment suggests few wide-scale negative impacts of marine renewable developments at the population level of organisms. They don't seem to be particularly likely. Though clearly, once we have some of these major developments in the environment, more coordinated studies are needed to actually get these answers. And the way things are going, these are going to come from other parts of the world where these devices are being deployed quite extensively. Design and location are obviously key to minimizing the impact, but this shouldn't necessarily detract completely from developing these devices and getting them in the water. And it could be argued that the major impacts could be positive. And industry really needs to work much closely with fisheries people, with conservation agencies to try to develop this positive value and maximize what we get from any bit of marine space devoted to these devices. So really, we need this partnership. As we've talked about partnership in fisheries, we need a partnership to help develop marine renewable energy, to look at co-location, enhancement, conservation areas, etc. And as Friends of the Earth said to me, it would be a real shame if the reason that marine renewable energy doesn't develop in the UK to help combat climate change is because of the major objections to the environmental impacts. It seems a bit of a wrong reason for not doing it. The key problem perhaps remains people don't like to look at them, particularly wind farms. And that is something that's obviously a separate issue, but it's something that's just worth raising. So thanks very much, particularly to our team of co-authors at both Plymouth University and Exeter University who've been working on this. Thank you.